Hi guys, welcome back to my channel. So in this video I'm gonna show you how to prove that a vector field is conservative. Okay, and to prove this we'll have to show that the curl of the function f, so this is the function f that is given to us, is equals to 0. Okay, and in my previous videos I have shown you guys how to calculate the curl. Okay, so the curl is calculated using this equation, so we'll have to prove that this equation is equal to 0 to prove that the vector field is conservative. Alright, but before we go ahead and do this, this is a really ugly looking equation, right? And I'm sure you're not interested in memorizing this equation, so I have a trick for you guys, so you don't need to memorize it because it's not given in the memory aid, because when I took the exam the teacher explicitly said that you have to memorize this equation. So you don't need to do this. I'm gonna show you a trick over here. So here you guys know from my previous video where I made on the curl, right? If you have been following the calculus 3 playlist, if you're not, then it's okay, I'm gonna explain it over here again. So here this if you have a given function f, so the first I hat component, I mean the x component, is you consider it as the p, and the second one, the y component, you consider it as q, and the next one is considered as r. So p, q, r, just like x, y, z. Okay, and since p is associated with the x component and q with y and r with z, so you're going to write them side by side. Okay, so the p is associated with x, and then q with y, and then r with z. Okay, and to be able to arrive at this equation, first we have I hat, right? So let's write I hat over here, and I hat means the x component, right? So we're talking about the x component, so we're simply going to cross out the x component, right? And next we're simply going to take the determinant. Guys, remember taking the determinant, you guys do like this times this and then negative this times this, right? But here we're not taking the determinant. Okay, we are working in the same idea, but we are working in the reverse direction of the determinant. So determinant, you go like top to bottom, right? But in here you're going to go from bottom to top. Okay, so bottom to top, you're going to cross it out, r times y, and then negative top to bottom. Okay, so r times y, negative q z. You see, we're starting to get at this equation. Okay, next, so what do we do next? Okay, so I'm gonna remove these lines. Next we are at j hat, and j hat, just remember that it's always negative, right? Just like we do in the determinant, we always put the j hat negative, so here it's the same thing, negative j hat. So now we are in the j hat direction, which means we are in the y component, right? So we're going to cross out the y. Next we do like same way, crossing out the y and then multiplying from bottom to top, so r times x, and then negative, right? And then negative top to bottom, pz. Okay, you guys see? Yeah, so it's the same equation, and at the end now we are writing with the k hat. K hat means we are in the z direction, so we are going to cross out the z. Okay, so we are going to cross out the z, and we are going to multiply in the reverse direction of the determinant, so q times x from down to from bottom to top. Okay, q x, and then negative top to bottom, py. Okay, and this is how you arrive at this equation, right? So you guys really don't need to memorize it, just use this trick and you'll arrive at this equation. And it's pretty quick to arrive at this. It's just that I was explaining you guys, so it took me a little longer. Otherwise, if you do it quickly, it won't take you long. Alright, so if you want, I can remove this because this equation is simply written over here. I was just showing you how to arrive it with the trick. Okay, so now let's finally calculate the curl f equals to 0. So this is how we calculate curl, right? So to find the curl of f, first we're going to need r of y. So what does this ry means? So this ry is simply like the short notation of writing the derivative of the r with respect to y. So this is the same notation. Okay, so here this is the r. So you're taking this function r over here and you're differentiating with respect to y. And similarly here, q of z. So you're taking this function q, you're differentiating with respect to z. Okay, so this is what we're doing. So let's find the missing components over here and then plug into the value. So first of all, we need q of y. So we need to find q of y, right? What else do we need? We need qz. So we need qz. We need r of x, we need pz. I'm just separating p, q and r over here. Okay, what else we need? q of x and p of y. So these are the things we need. Next, we can simply, after finding it, we can simply plug it into the equation and see if it's 0 or not. If it's 0, that means it's conservative. If it's not, that means that it's not conservative. Alright, coming back to the problem over here. So here, p of z. Let's calculate p of z first. So here, this is the function p. We're differentiating with respect to z, okay? So here, this is the first part. There is no z over here. So that means this is simply 0, right? So this is 0 because this is a constant. Because it's partial derivative, we're differentiating with respect to z. That means that x and y are treated as constant. Okay? Alright, so we are left with this one. And this is the derivative of, if you have like derivative of e to the power of 2x, how are you going to calculate the derivative of this? So first you're going to write the same exact thing, e to the power of 2x, then you're going to multiply it by the derivative of the inside function. And what's the derivative of 2x? The derivative of 2x is simply 2. So here 2 e to the 2x is the answer to this. So this is how you're going to calculate in here. So here you have e to the power of 3x, e to the power of 3z, and then what's the derivative of the 3z? So derivative of 3z is simply 3. So you're going to write 3 over here. Alright, so then we have p of y. Okay, so we're differentiating with respect to y. That means x and z are constants over here. So this is a constant, it's going to remain over here. And then sine of y. So here the derivative of sine of y is cosine y, right? And then since it's a constant and it's written by itself, so this is 0. Here this is not a 0 even though it's a constant, because it is attached to the sine of y, right? And we're differentiating with respect to y. Here there's no y, only z by itself, so this goes to 0. Okay, so next we have q of z. Okay, q of z. So here this is the function q, with differentiating with respect to z, and then x and y are treated as constant. Okay, and do you guys see any z over here? No, right? Only x and y, and x and y are constant, so that means this is 0. Alright, so what is q of x then? Okay, so we're differentiating this with respect to x. So this 2 goes down, and then this is a constant, so it's going to stay over there as it is, cosine y. And r of y, differentiating this with respect to y, but you guys don't see any y over here, only x and z are constants over here. That means that is 0. Okay, r of x. Now this is x. The 5 is, it's gonna go to 0 since it's a constant, so we're differentiating only this part. And here z and y, since we're differentiating with respect to x, so y and z are constants over here. So here you have this thing with a z, so that means this is a constant, so e to the 3z is a constant, it's going to stay over there. So differentiating only 3x, and the derivative of 3x, it's only 3. So this is the answer to r of x. So now we can plug it into the formula and see whether it's 0 or not. So we have ry minus qz, right? Ry minus qz. So we have ry, which is 0, minus qz. Where's the qz? Qz is 0 as well. Okay, so we do have 0 I hat. So now let's see if we arrive at 0 or not. Then we have qx minus pz. Qx minus pz. So we do have exactly the same thing, right? 3x minus qz. So this is indeed equals to 0 as well. So next, what do we have? For the k hat, qx minus py. So qx we have 2x cosine y, and then py we have 2x cosine y as well. So that means we have the exact same thing over here as well. So this is 0 as well. So here, that means it's proven that it's 0 I hat, negative 0 j hat, plus 0 k hat. You do need to write this, otherwise you'll lose mark. K is indeed equals to 0, and you have shown that curl of f is equals to 0, and it's proven that the vector field is conservative. Thanks for watching. Bye.